Good evening. My name is Mike Stish. I'm editor-in-chief of Hackaday.
My name is Sophie Kravitz, and I'm director of product at SupplyFrame.
Very good.
What?
I'm going to do one more time.
You guys heard me, right? Okay.
We had a lot of fun making those videos. I think what's really incredible is the people you see working the conference this weekend. A lot of them are what made those videos happen. And at their core, it's because our community is a community that likes to make things. The Hackaday Prize began when SupplyFrame's CEO, Steve Flagg, looked at our community and saw all the talent that was there. And from one simple question, how can we use that talent to make good in the world, the Hackaday Prize was born. It's incredible to be finishing up the 4th year of the Hackaday Prize. Hackaday Prize asks designers, hackers, and engineers everywhere to take some time in their life and to apply their skills to make the world a better place. The Hackaday Prize asks you to build something that matters.
So I just want to take a minute or two to tell you guys what we've done in the last 4 years. We started in 2014, and the winner was a project called SatNogs. And SatNogs, does anyone here remember SatNogs? All right. So SatNogs was an open source ground station for satellite tracking, and we actually built one of those at South by Southwest the following year. At this point, we realized when they won the strength in our community collaboration, because this was built and a group of 10 people won from 3 different countries, from Greece, the Netherlands, and Germany. The winner of the 2015 prize was iDrive-O-Matic, and iDrive-O-Matic is a wheelchair that's driven with eye tracking software. It was developed also a collaboration with 3 men, all from the UK. Unfortunately, they all had motor neuron disease, which is very similar to ALS. Unfortunately, 2 of those men passed away earlier this year, and I'd like to just take some time to recognize both Patrick Joyce and Steve Evans. This past April, Cody Barnes, a friend of the family, wrote to us, "I am sorry to report that Steve Evans has passed away. Steve selflessly found a way through iDrive-O-Matic to help many others with similar struggles. The loss of Steve is a major blow to the product." 2 days later, we heard Patrick Joyce had also passed away. Cody says, "Patrick was involved in several projects that so clearly demonstrated his compassion, creativity, intelligence, and inability to give up. And in fact, his Facebook page is called Patrick the Optimist." This sounds really cliche, but it is true nonetheless. Patrick and Steve did their part to make the world a better place. To recognize the work of these 2 really great people who are no longer with us, let's join together in a round of applause for them. This project continues, and if you'd like to help out on this project, please see someone from Hackaday and we'll put you in touch. 2015 was the first year that we ran the Best Product Prize. Vinduino was the winner, and that's an IoT sensor system that reduces water waste in agriculture. Rainier Vanderlee, the winner of the first Best Product Prize, shows us that there is still low-hanging fruit in conservation technology. And last year's Hackaday Prize was a search and rescue robot designed to go into small places called Ditto. It was inspired by a project built in 2005. It was completely redone, made open source by Alberto Molina Perez, and I think someone's clapping for him over there, because he's... The documentation on Ditto is incredibly impressive. You can actually build this project straight from the documentation on Hackaday.io. Alberto came to the United States. We invited him to come and do a residency at the SupplyFrame Design Lab. He was here for a few months, and he's back. I saw him this morning. This is really important work. Joining us in this are our partners, the companies that sponsor the 2017 Hackaday Prize: DigiKey, Microchip, Texas Instruments, and Supplyframe. These companies make the Hackaday Prize a really possible thing for us to do and allow us to do an event like this. So thank you again.
When it comes time to get a bunch of creative people to work on something that matters, it helps to have a few constraints. And so this year we ran the Hackaday Prize in several different rounds. All of these rounds were entry rounds, so if you didn't enter the first one, you could enter the second one. They ran about 6 weeks at a time. The first was design your concept. So this said, look at a problem, think of a solution, think of what it would take to build that solution, and make a plan before you even get started. We saw a ton of teams get together on this, and happily, a lot of these projects were actually made into prototypes and made it into other rounds in the contest as well. The second round is an interesting one for me. I see a lot of IoT projects that don't really make that much sense to me. And so we actually challenged the Hackaday community to build an internet of useful things, IoT, not IoT. There was a ton of purpose for those machines, and I encourage you to go and look on Hackaday.io at the lists that round up all of the entries and all of the semi-finalists in those. They're quite amazing. They're open hardware. You can extend that usefulness into your own projects. Wheels, Wings, and Walkers is all about motion. I think it takes an entirely different group of people to move the world. And so we wanted to see the people that were building robots, building mobility devices. We saw everything from wheelchairs to drones and from robots to bicycles in the Wings, Wheels, and Walkers round. Assistive technology is becoming more and more important to the world. We're realizing that the advancements that we've made can be applied to directly make an effect to an individual's lives, and those individuals make up large populations of people. There's a lot of good to be done here, and you should really consider it in your own builds. These are things for the disabled, things for people that need health care, and opportunities to ease issues faced later in life. We saw projects for mobility to assist the visually impaired. We even saw a project that helped improve the quality of life for people living with dementia. And finally, good ideas come from everywhere. And so we had anything goes as the final round. Anything that didn't fit into the previous rounds could be entered in this, and we saw an outpouring of builds that happened because of this. This year, we're also happy to bring back the Best Product Award. And so Best Product ran concurrently with all of the other challenge rounds. These are designs that go beyond the initial prototype. We're asking people to look at who is the user of this product, and what does it take to meet that user's needs, and how does that affect our ability to manufacture this and manufacture it at a price point that it's going to be able to be adopted by those users and used. And you look into things like durability, and I think the key for the Best Product Award is that for the finalists, we require them to send us 3 working beta test units, which shows that you've thought a little bit more. A lot of people can create one prototype, and then you say, well, create another, and they're like, oh, man, all that's point-to-point soldering. I can't possibly do that. Having people make 3 shows that you've thought, well, what if I had to make 10? Or what if I had to make 100? Or what if I had to make 1,000? I can delay this no longer. I think it's time to reveal the first winner, and to do that, please welcome Sophie Kravitz to the stage.
Thanks, Mike. So I hold in my hand the winner of the Best Product. This product incorporates one of the most ubiquitous things that we have in our society today, the smartphone. Wow. This best product was designed by a team of 5. So we have a collaborative product again. These people worked with a group of visually impaired people to learn more about Braille keyboards. This product can adhere to the back of a smartphone and has 6 buttons in a Braille character pattern. The user holds the phone with 2 hands and without blocking the screen is able to type Braille characters. It's simple and cost-effective, and could be transformative to the lives of others. So, the winner is TPO, Braille Smartphone Keypad. I think that Vijay Varada is here. All right. And you traveled a really long way to get here, didn't you?
Jet-lagged.
Where did you come from?
India, Bangalore. Wow. Well, thank you. Whoa. So I mean, 2 weeks back, I woke up with a jolt when Shuli sent me a mail. I mean, saying that they'll help me fly me over here, and that itself was unreal. And actually being here is I'm still jet lagged. I think I'm dreaming. But in all the excitement of, I mean, I was told to prepare an acceptance speech just in case something would happen. But with tension, waiting for the visa and making sure my passport comes back on time and getting the tickets, so I didn't prepare anything. So probably I'll just leave you with an update about what the journey of TPO and where it's heading now. So it started when I attended a conference that was hosted by my uncle who works with persons with disabilities. And at that conference, meeting these people, that is where my sympathy turned to empathy, and I sort of put myself in their shoes and understood the problems that they face. But it wasn't until the Hackaday Prize came along and sort of was shouting at me, build something that matters, that I could put all my thoughts coherently onto a project, build a team that covers all the bases, have good documentation. I mean, even the video that we had to make at the end, I mean, for an engineer, it's easy to sit for hours behind laptops, CADing or working on code, but 5 minutes in front of a camera is a lot more excruciating. But we but we got out of our comfort zone and presented ourselves, presented the project, and that got us so much attention. So we got covered by national press. I shared it on Facebook, and everybody started sharing it, and then somebody from the press got involved, put it up on newspaper. Then every single day I would get a call from somebody who was visually impaired. There were lawyers, there were engineers, there were people who wanted to blog, they wanted to manage the social media, and they said that this is something that I've always wanted. And I mean, it would be a crime on my part if I did not take this forward. I mean, I have a long mailing list of people who are just waiting for this to come out. So I thank Hackaday and Supply Frame and all the sponsors for giving me this opportunity and this platform to really bring TPO into existence. Thank you. Yes. So we have Ayushman, Lyle, and Prashant. Oh, thank you.
So we're going to announce the next 5 winners. But before we do that, I want to recognize the 16 amazing judges who helped us to judge the finals. So we have Chris Anderson, Simone Gertz, Dr. Anne-Marie Thomas, Anul Mahidharia, Anouk Wiprecht, Danielle Applestone, who will be here tomorrow, Mitch Altman, Dr. Dustin Roberts, Chris, who you may know as Clickstring from YouTube, Dr. Crystal Gordon, Eben Upton, Dr. Nadia Peak, James Bruton, Catherine Scott, Forrest Mims, and Kip Bradford. We invited these 16 people to judge the Hackaday Prize because we consider them experts in their field. They practice engineering, building, and design regularly, and they often publish their work publicly. We really appreciate that these people have donated their valuable time to judge a competition about making the world a better place. Some of these excellent judges were able to join us at the Super Conference, so you'll meet them as they announce the prize winners.
Before we announce the winners, we do want to take a look back at the top 10 entries and what the judges thought about them after their intensive evaluation process. Please enjoy this video. I think I'm the one supposed to start this. I'm sorry.
The adaptive guitar is an electromechanical system that allows someone to play the guitar using their foot. So they can hold the guitar the regular way, but the strings can be plucked and strummed even if you don't have a hand.
So I play guitar myself, actually, which is why I particularly like this project. So I thought it was pretty good because obviously it allows you to play the guitar with one hand. Basically, it's a sort of pressure sensitive. I'm still trying to work out what the pressure sensors are. They look capacitive, etched onto a PCB, where you can effectively touch this thing with your foot, and that does your strumming hand. And then you've got mechanical picks that pluck the strings. So I thought that was quite good because it was a nice rounded project that's obviously complete and works pretty well.
The interesting thing was creating different versions of the same device or the same problem that they were trying to solve. So they ended up creating 3 different ways of finding out veins. One was to use off-the-shelf hardware, Raspberry Pi, no IR camera and stuff like that. And then they hacked the webcam and removed the IR filter and did some hack in that and made it work with a regular computer. And then they finally also figured out a way to make the whole thing work with a smartphone. For me especially, it was very interesting because my wife has a medical condition that requires her to take an injection once every month. And I'm petrified of doing that for her. She's been telling me for the longest time to learn how to figure it out. But I'm just too petrified of, doing it wrong.
It can be easy to put out oh, hey, I made a pollution sensor, or hey, I made it easy for us to sense air quality. And taking that next step in a project where you can, for example, make a map. Is this sensor just reading things out to your serial monitor, or are you actually doing anything with that data? They're clearly demonstrating the fact that they can take data and put it onto maps and share that with stakeholders in a way that is immediately apparent.
I'm not sure how this compares to other systems, but it does measure 4 gases and it does particles as well. So it's kind of got 5 senses. What the particle measuring is using a laser scatter measurer or something like that to actually measure physical particles in the air. So I guess that's quite good. The other thing was the gas sensors only last 2 years, so those are all interchangeable on some sort of plug-in sockets that plug in, so that can be easily serviced. And I believe it's got a 15 to 30 kilometer wireless range as well, which is really useful, so it doesn't have to be put necessarily anywhere where it can be physically plugged in, or it's within Bluetooth or Wi-Fi range or whatever.
That it's sort of an intersection of health and engineering, right? That you could go in and grab this monitor and you could teach a health class, you could probably teach an intro signal processing class, you could teach intro electrical engineering. There's so many things that this device would allow you to do and to teach and to learn about at the same time. The fact that it can be, commoditized at this point is pretty cool because these sensors they're not cheap in a hospital, but when you can bring down the price and you can actually bring it into a home, I think that's what's more interesting. And just that you have this set of sensors where you could probably start looking at what people's biometrics actually look like in the wild.
This is a medical device for, it's basically an ECG patch, which is generally proprietary and quite expensive. So this has become something that's open source, so it can become much cheaper. And the sort of intention, I think, of the project is to make it more of a commodity thing, like people would wear a Fitbit or some sort of smartwatch. Potentially this thing could have a Bluetooth link to your phone, so it could monitor your heart. And the important thing is it will measure peak to peak. So you could actually sort of predict heart issues that might be a medical issue.
I think really democratizes an important piece of fundamental technology building block for medical device development outside of the professional biomedical engineering world. There are lots of people who I think can contribute to making medical devices better. And this is a good first step with that endeavor.
I started looking at what happens when you have a disaster or a calamity. In the earlier days, the only way of getting communication in or out of such regions used to be amateur radio operators. So this is pure genius. You take regular hardware, hack into it, put easy to power options to it, make it run through solar or battery or AC or whatever is available. Make it deployable via drone, so you can spread it out over a large area, and then each mesh, each router talks to each other, giving instant connectivity. And of course, in 2017, almost everyone needs internet connectivity. So even if you have amateur radio operators, what you really need is internet connection.
The open radiation detector, I thought, was a really nicely done example of a new sensor developed for a very, very, very important purpose, which is evaluating environmental radiation signals, whether it's from a nuclear disaster or background radiation, environmental contamination, or just awareness of your surroundings. One of the things that happened after Fukushima, we saw a massive uptick in the development of do-it-yourself radiation detectors because the government of Japan was not very forthcoming in telling people what was going on. And people really needed to know this information to be safe.
I really loved the open source underwater glider. I really felt like it was not only an extremely well done project, just the spec of understanding I need a long-term platform for underwater exploration, how am I going to have battery longevity through a really long-term mission. But also, there was so much care in that project put into how do I make this an actual platform rather than just I made this thing and it was for myself. From their model, from just their solid models and the videos that they posted of their glider working, the 3 different motor assemblies and how they interacted with each other and the way that air gets pushed in and out of different parts of the glider. It just seemed very well done.
So TPO is a Braille keypad that snaps onto the back of a smartphone and plugs into the bottom of it so that someone who can't see the screen can type. So you press different keys and different combinations and it's as if you're typing, but if you have a smartphone, there's no keys on it. So TPO allows people to use smartphones with no keys on the front if they're visually impaired. One of the other things I liked about TPO was just the creator and how psyched about the feedback he got was. It seemed like he didn't even realize how amazing of a project this was, and then he started getting some national press and people giving feedback and visually impaired people coming to him and saying this is a great project, and you can just see like in the comments his momentum is building, and he seems to really take that to heart, which I just thought was, it was really special to see someone so excited that their product is actually having an impact already.
I don't think there's enough of an open ecosystem where you could actually go learn how a phone works from the ground up anymore, right? Like when I was a kid, you would grab a phone that weighed like 30 pounds and you grab a screwdriver and you could crack it open and you could see how the whole thing works.
It's a labor of love to dedicate yourself as an individual or as a few developers to try to take on gigantic companies like Apple, or in terms of making infrastructure that people can use. And so having viable alternatives almost can seem like an unsurmountable task in the telecom industry. How are you really going to compete with a billion-dollar industry like that? But I think that alternatives are not only a way in which we have access to things that might better fit with our ethics. Having alternatives is also a way in which just people can learn about, what actually is in your phone? How do all these antennas work? What are you communicating with? What is a text message? And, why are they 7 cents? And so part of what I really like about the Zero phone is just that it's like a functioning phone, and you submit bug reports and they clearly fix them. It's a very engaged and lively community.
Hello. Presenting fifth place is Hackaday Prize Judge Dr. Nadia Peak. She recently completed her postdoc at MIT Center for Bits and Atoms. She works on digital fabrication and technology for humans and is currently a researcher in residence at Nervous System in Cambridge, Massachusetts. Please welcome Dr. Nadia Peak. Hold one or just speak?
So fifth place. Ooh, sorry, I will position myself carefully. It's kind of an exciting, but only first in maybe the prize round. I really liked this project that you might have already seen today because it's sometimes easy to make a product for a target audience without ever engaging with them or talking to them. You're just like, I know, I'm an engineer, I can fix your problems, I understand your problems. And it's not always the case that you really do. There's a lot of parameters that you might not take into account. And when an engineer takes the time to engage with the group of people that are going to be using it without saying, like, if you were smart, then you would be able to debug this. That's really refreshing and lovely. And so this project is really quite amazing. And the winner for fifth prize is the Braille smartphone keypad TPO. So I think I'm gonna come back up.
You may recognize TPO as they previously were awarded the best product tonight. Please welcome to the stage VJ. Yeah. What's your last name?
VJ Vardhan. Yes.
Right. Congratulations.
Thank you. Wait, this is, I don't know what to say. Thank you again. Thank you so much again to the community and the team and I can't believe it's happening. Thank you.
That was a $5,000 award. Presenting fourth place are Kip Bradford and Anouk Wiprecht. Kip is a research scientist affiliated with the MIT Media Lab, and he works on heating and cooling systems. Anouk is a fashion tech designer who makes dresses that use sensors, machine learning, and other kinds of robotics. Please welcome Anouk and Kip.
Cool. So how are you all doing? Yeah? Enjoying yourself? I can barely see you guys. Who is not enjoying yourself? Pull up your hands. Yeah? Okay, I think we're good. We're good. Yeah. I am definitely having a blast here. Cool. So this project's description has a nice story. The project was started for a friend who suffered an injury during a skiing accident where she severed the motor nerves that controlled her left arm. One of the most devastating parts of her situation was that she was an avid musician and loved playing her guitar.
This might give it away before I open the envelope with Anouk, but the family of this person searched the social networks, searched her social grapevine for somebody who could help build her something that would allow her to play her guitar with one hand. The grapevine ended at the person who made this project, and the fourth place winner is...
Da-da-da-da-da.
The suspense is killing you.
1, 2, 3. Joseph Pinzone
with the adaptive guitar. So...
Yeah. Unfortunately, Joseph could not be here, but I guess we have a movie. And congratulations, Joseph.
If you're watching this, something unexpected has happened. and it's one of the coolest things that's happened for a project of mine. I'm Joe, and the Adaptive Guitar Project has been a passion-filled multi-year project for me, and I'm seriously excited to have it win a Hackaday prize. Even though it's just my name on my profile, there's a handful of people that deserve a lot of credit and thanks. First and foremost, thank you to the Weinstein family, Dr. Steve and Ellie, and their seriously brave daughter, Rennie, who was the reason and inspiration for the project, and her brother Brian, who tops off one of the most fun, inviting, and deserving families I've been welcomed into. The Weinstein family fronted a large amount of financial support and patience for the project, which, as you know, are both pretty critical resources across the board. Thanks to Rob Kranick, who taught me everything I know about machining and was an instrumental advisor from start to finish on this project. John Bonzo, who donated a lot of time and resources at his CNC and 3D print lab to bring the project to life. And Terry Gastauniotis at Small Parts CNC in California, who started off as a vendor but ended up being a friend and advisor who really helped me make the design come together for manufacture and actually work. Like many good projects, of course, this project started in my parents' basement back in the day, and it was actually their kitchen table and spare bedroom, but thanks Mom and Dad, of course, for keeping me focused and pushing the project forward. So last but not least, the Hackaday community deserves a big thanks, not just for creating the Hackaday prize, but for being such a great community of inspiring people. I've been a reader of Hackaday since shortly after it went live, and the projects and people in the Hackaday community have inspired and educated me and expanded my engineering toolbox so much that the Adaptive Guitar Project and many of the other projects that I've done would not be the same or maybe even successful if it weren't for you people out there who contribute and show people like me how to do things, or more importantly, how to not do things. Finally, I'd like to acknowledge all the projects that were submitted for the Hackaday Prize this year. I really didn't anticipate making it this far, let alone being awarded a top prize, because there were so many deserving makers and projects out there that were submitted this year. So everyone did an amazing job. I'm grateful to be a part of it. Keep building, keep hacking, keep inspiring, and most importantly, keep making things that matter. Thanks, everybody.
Thank you so much, Kip and Anouk, for presenting that. The Adaptive Guitar, winning 4th place, is also awarded a $10,000 prize. Moving on to 3rd place and a $15,000 prize, I'd like to introduce another Hackaday Prize judge. Dr. Crystal Gordon has her PhD in electrical engineering and designs bio-inspired and bio-interfacing systems using high-speed electronics and models of complex systems. Please welcome to the stage, Dr. Crystal Gordon.
Good evening, everyone. This particular project was extremely interesting, and it shows what a talented group of kids and a great idea can do. So, for many instances, medication can't be ingested through the gastrointestinal tract, and it has to be injected in an intravenous fashion. Usually it's done by a doctor, but unfortunately, you can't necessarily inject the medication yourself. The aim of this particular project was to find another method of having the medication being intravenously introduced for people. It's a thing that we take for granted, but thankfully, this particular team came up with a fantastic solution. The winner of the 3rd place prize is the Assistant System for Vein Detection, and the winners are Miriam and Elias Stotzer. Unfortunately, Miriam and Elias could not be here, so they sent us a video from Berlin.
Venous blood vessels used for medication are not always easy to recognize, and if the needle is not secure in the vein, it must be punctured again at another point. Literally a painful experience. This is usually done by specially trained medical staff. For chronic diseases like hemophilia, it can be a part of the home treatment. Here, our project Venfinner comes into play. Using near-infrared illumination and image processing, we can make the veins more visible. This is especially important for children to boost their confidence when learning self-administering their medicine. A total cost of about €100, while professional medical devices for vein detection easily cost €3,000 to €4,000 for roughly the same results. We would not have thought of getting such a huge and positive feedback, and we would like to thank the jury, the Hackaday.io community, and the Hackaday readers from all over the world. Thanks a lot and many greetings to the Hackaday Super Conference.
Let's have another round of applause.
The second place award, $20,000 award, will be presented by Catherine Scott. Catherine was the lead developer of the Simple CV computer vision library and co-author of the Simple CV O'Reilly book. Catherine is a senior software engineer for Planet Labs, where she works on the data pipeline team, making sense of millions of satellite images. Please welcome Catherine Scott to the stage.
Everyone. Basic vital sign and health monitors are seldom low cost and reliable at the same time, which means that these machines are usually only available in hospitals. These machines are not platform portable and require expensive services and analytics software. This project democratizes medical hardware to diagnose a patient's health from a remote location and uses to do it cheaply and readily using a Raspberry Pi to do so. So, without further ado, the second place prize goes to Ashwin Whitechurch, Venkatesh Bhatt, and Manikandan Selvaraj for the Connected Health Open Source IoT Patient Monitor. So Ashwin's here. Do you want to come up? Congratulations.
Yeah, thank you. So, yeah, this was a surprise. So honestly, this started out as a weekend hack of ours. We just started, we had all these vital sign devices that we were making. And then we thought, how do we make it more accessible? So, and the Raspberry Pi was there. That was the most common computer in the world. So we made a hat for the Raspberry Pi. And initially it just started like that. And then I put it up on Hackaday. We had a lot of, honestly, that was the first time I'm putting anything on Hackaday. So, and first time I'm using Hackaday actually. So, but the response that we got and the feedback that we got from the community was so big that we continued putting other projects also on Hackaday. And the response for those also has been really good. So, thank you.
So we're getting close to announcing the grand prize. We've seen the winners of the 5th through 2nd prize entries. They're covering technologies that help improve quality of life for people. Our 5th place winner created something to help people who are visually impaired. Our 4th place winner created something to help a nerve-damaged friend play music again. Our third place winner designed a device to help find veins for intravenous injection, which is so important to people with chronic illnesses. And our second place winner showed us how diagnosing those illnesses ahead of time is really, really important. These are indicators for the issues and technologies which are just now beginning to get focus in society. We, all of us here today, we have powers as engineers and technologists to find ways to apply progress to the benefit of all. And so, without further ado, please welcome Mike Stish to the stage to present the grand prize.
Thank you. I can feel my heart beating. I hold here the trophy for the 2017 Hackaday Prize grand prize winner. This project makes possible long-range and long-duration underwater exploration. It utilizes commodity hardware, 3D printed parts, and open-source autopilot. It reduces the cost of underwater projects and creates the opportunity for university research, small shop startups, citizen scientists, and yes, even hobbyists. The grand prize winner of the 2017 Hackaday Prize is Open Source Underwater Glider by Alex Williams. I believe Alex is with us today. Alex, are you here? Please come forward. In addition to being named the grand prize winner and being awarded this trophy, the Open Source Underwater Glider will receive a $50,000 cash prize. Put your hands together for Alex Williams. Congratulations.
Wow. Yeah. Give me a second. Unlike the others, I wasn't actually told to prepare anything, so wait. So, wow. When I started this like 8 months ago, 9, when I was aware the Hackaday Prize was going to start, it was just a small thing, as like a small hobby thing in spare time. I'm shaking. And then won some money from the first round, and that really helped because I could do stuff that I couldn't previously. I got underwater. It's getting to me. Underwater tubing, and that really helped with everything. So seed funding helped. And then as time progressed, I did more and pushed the hardware further, and it's now at the stage where I want it to be possible for anyone to replicate it. So I thank everyone at Supply Frame Hackaday and the entire community. Thank you.
Thank you. If you want to go off stage right, we'll have you come back in just a minute. Unfortunately, that brings this year's Hackaday Prize to a close. I'd like to make one more thank you to our key sponsors who made this possible: DigiKey, Microchip, Texas Instruments, and Supply Frame. Please give them a round of applause. My keynote skills are not all that great, so let me grab my last set of notes here, or not. Making a difference in the world doesn't end with the award of the grand prize. Over 1,000 projects looked at solving problems that face the world in this year's Hackaday Prize. But we want you to continue on. Use your time and talent to improve lives and to solve problems. You are an important part of the framework of human progress, and I really do mean that. You are important, each and every one of you, and especially when we work together, we have the power to move things forward. Carry that responsibility proudly, and you will become part of something much larger than yourself. Please join us in celebrating these ideals. The Hackaday Prize Party begins now. We have food, drink, badge hacking, games, music, and socializing next door in the Design Lab. If you are a Hackaday Prize finalist, judge, sponsor, or Hackaday staff, please join us on stage for photos, and we'll see the rest of you in a few moments. Thank you and have a good night.